what I'm hoping is that we are at the point of just doing what we've normally done, and we're just putting a couple of extra little bits and pieces, making sure you can use your technology nicely to do stuff. So, where we left off last lesson was stuff like this, right? Blah, 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 blah. Fully factorise, given that x plus 5 is a factor. Now, if that was a question, it might not have even given you x plus 5. It might have just said, fully factorise. The first thing I would do is go to my calculator. I'd be keeping my fingers crossed, going, because it said fully factorise, maybe it's only worth 1 mark. That means I'm hoping it just comes up straight away. Okay? So we go 3. Everyone's happy how we're using our calculator. Like, quick. 1, 4, minus 11, minus 30. I even remember. Oh, it's still in there. And we go enter. Huzzah. I could just go, sweet. That's x take 3, x plus 2, x plus 5. My job is done here. Sweet. I do just double check that if I just did this on the calculator, what did I just say? X take 2, x plus 3, x plus 5. I do a quick little check because at this point, right, I have to check that this times this does give me minus 30, right? 3 5s are 15. 15 times 2 does give me minus 30, because if that was instead of minus 30, it was minus 60, like everything had times by 2. So what am I trying to say? If I had 2, you can do this now actually. Get your calculators. Go 2x cubed plus 8x squared, take 22x, take 60. Put those values in. And hopefully, if I know my maths, what you will end up with is the same values. You will still get x equals 2, x equals minus 3, and x equals minus 5, right? But you can't say, what? You should. You can't say that this equals, right? If you then went this equals x take 2, x plus 3, x plus 5, you're going to get a big fat no. That's wrong. Do you see why? Right? So this doesn't equal, you would actually have to put a 2 out the front. And then that is the same. So that's because, remember, the 2 out the front stretches your graph or flips it upside down. But it can still have the same zeros, but the graph can look actually quite different. Capiche? So do be careful when we've got that. All right, use your calculator. Let's see what this one does. So what are we going to enter into our calc? No, we're going to go 1, and then it becomes x squared. So if we look, there is no x squared, so we're going to have to put 0 and then negative 12. And sorry, people on the microphone, I'm yelling because I'm talking to the people at the back of the room. And 16. But hey, you can turn the sound down. All right. Ooh. Now, how do we write this if we're just using technology? What does this times 2 mean? Yes, Tom? Same root. So what do? Square it. It's a repeated root. So for b, we would have to say, oops, forgot already. So x minus 2 squared. And x plus 4. Okay, we check. This is like a 1x cubed, so we know we're not going to have to put a number out the front. That's it, done and dusted. Agreed? Yes? Yep, okay. That into your calculator. Okay, so we're going to do this one now. We're going to do it again now. No calculator, so calculators to the side. What do we do? Dan the man? Right, good. So we're writing this down. Exercise 4C, pop today's date. We've got x cubed. For those of you who are going, I've got this, I'm happy. What I would like you to do is progress. You can finish question 3. You can do it without calculator. See if you can mix it up. Right, I'm not going to tell you which. You could have both. I could put these questions in both. I will put these questions in both. All right. So for those who are still playing with me, and by the way, you can then carry on to 4D1. It's all the same, I believe. X take 2 as a factor. So that means we can go, this means X, I said take and I wrote plus, X take 2 is a factor. So what do you have to now times by so that we can expand and we get this? Now obviously, X times what gives me an X cubed? Right, this has to be a quadratic in here, right? It's got to be a quad. So it's X squared. I should be able to get that term. And I should be able to get the last term. Do we agree? Yeah. So minus 2 times what gives me 16 minus 8. Excellent. But remember, there's this term in the middle. Now, we don't know what it is, do we? So by this time, we should get used to the fact that we call that bx. Happy with that? Who can remember what we do now? Got to find stuff that makes x, and we take the next power, I guess. So we've used this. I'll go different color now. We've used the x cubed already to get this thing here. We've used the 16 to get the 8. And so your next one over, you could go for 12, but I'm going to be a bit sneaky. And I'm going to say, well, I'm actually going to use x squared. It doesn't appear here. So what's its coefficient? 0. That's right. Gotta love 0. 0 always makes my life easier. Okay? And now we look at this whole bit here. How do we actually get x squared? Well, you get an x squared by timesing x by x. Do we agree? So that's actually b x squared, correct? And we get, how else do we get an x squared? The minus 2 and the x squared. Thank you. Knew you had that, Hamish, too. Yeah? So now we just look at the coefficients. The coefficient of this one is b. The coefficient of this is minus 2. And now you can solve for b. B has to be 2. And you're going, geez, this was so much easier if I just had my calculator. Yes? So what we now have is we've got x take 2 times, I'm reading along here, x squared, what did we just say b was? So plus 2x minus 8. And we have to look at this now and go, all right, can I factorize this? Can you factorize? Right? What two numbers times together gives you 8 minus thereof, but adds up to be 2. So we don't have to, hopefully, we don't have to go back and do a whole lot of practicing factorizing because we're getting the practice in here. Do you see how this sort of repeats? That's a good thing, I hope. So, for those who forgot how to factorize, quickly, you start with 1 and 8. Does 2 go in? 4 times is 3. No, does 4? Oh, it's already there. So what are the only pair that's going to give a difference of 2? 2 and 4. So we end up with positive 4 minus 2, and that's how we end up with our minus 2 all squared. Okay, so this is I do this with my Specky kids, and I think they should teach this in your textbook at year 11, but they don't. So you try and work out what's going on here. What goes on in my mind? It's a strange, strange situation. All right, so notice we're looking at this. Where am I pulling these numbers from? So that's not a massive mystery, is it? It's just the coefficients. Yeah? All right. Minus 2 is a factor, sorry, x take 2 is a factor. So if x take 2 is a factor, Brody, what would the 0 be? If x take 2 is a factor, are you saying this to me? Yeah, 2 is my 0. So pop that there. Nothing difficult, correct? Saskia, you're going to love this, watch. Coefficients, the 0, I put a 0 here. All right, this is where you got to pay attention, kids. We add 1 plus 0 is 1. 2 times 1, 2. We add. We times. We add. We times. And you're going big whoop doop. Well, 1, 2 minus 8. 1, 2 minus 8. Okay, you are concentrating, not talking. You're doing C. You can start before me. All right. So we're going to do this without a calculator. Then we're going to do it with a calculator because we're not sure where it would be in the test. It could lob on either end of your test. So here we go. Non-calculator first. Given x plus 4 is a factor. So that means we're going to go x plus 4. Amara, I need you. All right. So we're saying here x to, oh no, this wasn't the bit that you were. Fly. It's a fly. A bug. X times what has to go here? Not so. I would disagree. It is not x squared because if you have an x squared there, x times x squared absolutely gives me x cubed. What do I want? 2x cubed. So what am I going to have to put there? 2x squared. That's right. We happy with that? Okay. Oops. Same old now. We then go to the constant term. 4 times what gives me negative 36. Negative 9. And all of those teachers from primary school who said, oh, in year 8, oh, you don't need to know your times tables. Rubbish. Okay, and do we know what goes in the middle? We do not know what goes in the middle, so we call it bx. So far, so good? Okay. We have used the 2 already to get this 2 here. We have used the minus 36 to get the 9. So now we just go to the next one, right? If Dan wanted to use the coefficient of x, he could. If Ed wanted to use the coefficient of x squared, he could. You'll end up with the same answer. I just go the next one, right? So we go x squared. On that original, it's 5. So sorry, this is when I need you now, Mara, right? How do I get an x squared? Isn't it going to be x times x? So that's bx, so b. And then how else do I get an x squared? Correct. 4 times 2x squared, which is 8x squared. So again, I just put the 8. Don't include the x's, right? They're just telling you the coefficients. Can we now find what b is? Yep. So therefore, b equals negative 3. And that means, that gives that my polynomial, so forgive me for not writing out this whole 2x cubed, blah-de-blah-de-blah. I'm just saying it's p of x. It's now equal to x plus 4 times 2x squared instead of bx minus 3. Yeah, everyone happy? And we've still got our take 9. And we're very proud of ourselves and pleased that we got that far. But remember, the question has asked us fully factorize. So we now have to look at this quadratic and see if we can factorize it. And so we're getting practice again with one of those that has a number out the front. I love this. All right, who could explain how they do that? It's silence. It's like crickets in here. Normally they're so chatty. Right, so we go through the routine. Everything's on one side, of course it is. Is there a common factor? We look at the two and we're really hopeful. Oh, our hopes are dashed because it's not an even number, right? So we go, ah. So we're going to take a couple of seconds, 5 if that, to see if I can factorize. So the only way I can get 2x squared is to say 2x times x. The only factors of 9 are 1 and 9 and 3 and 3. Right? So your choices are, could I possibly go, or would I even bother with 1 and 9? No, Ed's shaking his head because we've got 2 9s are 18, and the 1x, there's no way that's going to give you the 3. Agreed? What about going 9 and 1? No, 2 times 1, right? 2 times 1 is 2x, and 9 times x is 9x, 9 and 2, you can't get 3 from that. So, lo and behold, that leaves us with 3 and 3, and we don't even have to mess around because they're the same number. But we will double check, right? Always check. What's 2x times 3? 6x. What's 3 times x? 3x. So that means I can get, where'd I go? I can get a minus 3 from there, can't I? But it's got to be minus 6. So where am I putting my plus and my minus in the brackets? The final bracket has to be minus because it's 2x times minus 3 gives me the minus 6x. Yeah? And I will always argue that factorizing these, you don't need splitting the terms. You just need to know your times tables, and if you are good at expanding, it's done really quickly. So if you're struggling with this, do some more expansion, or call me over in the next couple of minutes and say, can we go through some more of these? I've got heaps. All right, and that, people, we are fully factorized. Dylan, just for you, if I wanted to do my synthetic division, okay, I put the 2, I put the 5, I put the minus 21, I put the minus 36. I put negative 4, I go 0. 2 plus 0, 2. Now I times. Minus 4 times 2, minus 8. I add. I times. I add. Oops. I times. 2 minus 3, 9. 2 minus 3, 9. It's so neat. Okay, so peeps, this is where some of you are going to now break off and focus on specific skills, because some of you are now telling me you have forgotten, or maybe you never were that confident in factorizing these expressions without your calculator, right? There's not going to be oodles of these in the test because we haven't got time for that, but these should be gimme marks, not, oh, I'm going to ditch that 2 marks. So, is there a common factor? No. We put the 2x, the x, right? And we're not guaranteed that this is going to be factorized. If I can't factorize, then I'm going to go quad formula, yeah? Okay, ready, Sask? So we look at the 12, I go 1 and 12, does 2 go in? 2 goes in 6 times, does 3 go in? 4 times, does 4 go in? It's already there, bang. All factors are done and dusted. And now it's just a game of, how can I get the 5 in the middle? And this is my thought process. 1 and 12. I do a quick little check. There's no way, if I put the 2 times 12 and a 1, I'm not going to get 5, right? 24 and 1x, no way to get the 5. What if I put the 12 here and the 1 there? I get a 2 and a 12. No way, I either get 14 or 10. That doesn't work. Goodbye. I'm not even going to bother with the 2 and the 6 because they're both even. When I times an even number by anything, I'm going to get an even number again, correct? And can I then get an odd number from 2 evens? So again, no thinking here. It's gone. So now I'm playing with 3 and 4. And again, if I choose to put the 3 here, 2 3s give me an even number, and that would give me another even number. Any chance I could get an odd from that? No. So logic tells me, before I'm even checking my expansion, it's just pure logic that is telling me the 4 has to be here and the 3 has to be here. Can you see that? There's a bug there. Got it. I've got some spray, but it's very stinky. All right, and now I want positive 5. So 2 times 4 has to be plus 8x. Take the 3x. Some of you, if you are struggling with this, let me know. I can go through it with you. There's heaps that I can give you to practice. But it's a skill that we should have. Talk to me. Question 4. X plus 3 is a factor. Tom, can you say that in another way? No. Karen, can you say X plus 3 is a factor in another way? Say it differently, but it means the same thing. Pardon? Negative 3 is the solution. Jazz, can you say it in another way? Instead of saying negative 3 is a solution, negative 3 is a root. Thank you. Yeah, you got to think of another one now. Solution, root. Think end of the alphabet. 0. Alex, what's another way? Last way. X plus 3 is a factor. That could mean minus 3 is a root. It could be a 0. It could be a solution. It could also be where the graph cuts the x-axis. Yeah, you got to speak up. I can't hear through the mask, yeah? Right? So I'm not going to use word for word that the book uses, but make sure you understand what that means. All right. On that note, find K. What are you going to do? Coops? X plus 3 is a factor, and they want you to find K. We've actually got various options for this. I'm going to go with what Karen said. That means minus 3 is a 0. So if you, Ellie, if you sub in minus 3, what should that whole thing equal? 0. So that means you should then be left with the value for K. Instead of talking, can you actually digest this and go, ladies? When I'm doing that, this is your opportunity to look, digest, understand, and think, what is it that she just said? Not just lean back and have a conversation. So if x plus 3 is a factor, you could do the whole, okay, let's equate x plus 3, and that means it's going to be x squared plus bx, what does that have to be, plus 9. But you've now got 2 unknowns. Your life might get a little bit more complicated. So what I'm saying is, let's use this fact right from the get-go. And we know that when we sub minus 3 in place of x here, so minus 3 cubed plus 9 times minus 3 squared, take 3k plus 27, the whole thing should equal 0. Do you agree? So I should now be able to find k, huzzah, slap it back in, and then you do exactly what we did before, and you can equate the coefficients. Cooper might go, no, I just want to do this, and I'm going to equate the coefficients at this point. Feel free. It'll still work. Okay, so for D1, you can start skipping a little bit because x equals minus 2 is a solution. Isn't that just like we just did? Because all they've done is instead of saying x plus 2 is a factor, you listening, Jazz and then Amara? I could have written this and said x plus 2 is a factor, and that means it's exactly the same as this stuff up here, correct? So you're repeating again, it's just worded differently. Don't look at that. That's them doing the, oh no, they are now equating coefficients before they expanded the whole thing. So if you want to look at that, feel free, the example, but it's the same deal that we're doing, okay? Use factorization to solve the remaining solutions. Again, be prepared that it is getting towards, you might end up with a quadratic left over that you cannot factorize, and so then you would have to use the quad formula. Think of someone who's writing the test. That would be great, because then I'm not doing the same thing over and over again of factorize. It's like, oh yes, now I've also got them, I can tick off, oh yes, they can use the quad formula. So, you're working your way through solution using technology. Okay, I wouldn't be doing every single one of those, but again, I will give you one where, Brody, you might have to get this. Instead of me telling you that the solution is 2, you'd have to use your calculator to get that, and then the rest of it would be decimal answers, and so you would have to use equating coefficients to actually solve. So, you working your way through for the next, let's say 10 minutes, and then you can have the remainder to continue working on your bookwork, or you can do your investigation.